Welcome everyone to another episode in the partner series. Today we're going to be talking about how AI is changing software delivery, because what we're seeing is that AI kind of isn't just accelerating delivery, but there's a whole bunch of structural changes that are happening around it in terms of how kind of value is negotiated in enterprises. So it's a shift away from how much effort and input is put into software delivery and more about what the outcomes are. So we're going to be hearing from Matt from Exec and Jay from ecosystem.ai, and they're going to be unpacking what this looks like in practice, and then also some of the kind of unforeseen consequences that we're seeing coming up. I'll hand over to you guys.
Awesome. Thanks, Nicola.
And as always, if you have any questions, just Q&A and I'll to Matt and Jay.
Yeah, so thanks everyone. This time we don't have any new special guests. It's quite a familiar face in mine and it's quite a familiar face in Jay's. And I think what makes it special is that Jay comes from the AI world. I've come from the traditional software world and moved into the AI world. And there's been some really, really interesting things that have been said in the media. And we're going to be as provocative as we can. We're going to upset quite a few people, probably from my old companies and fraternities like that. But it is real stuff that we're talking about. You know, a little while ago, Jay started speaking about this stuff. And because I come from the software delivery world, we had made lots of money through selling people hours. I was like, no, this guy's crazy. I mean, I was really doubting you for a second, Jay. Now, I'm on your bandwagon. I'm so glad when we started the business that we got really pushed around how we're showing value through our proposals, because we don't put out proposals anymore selling hours. We really focus on outcomes. But I think the big thing is, a few years ago, if you asked any parent what they were pushing their kids to study, they would have said, oh, software engineering, the world's so short on software engineers. I can tell you right now, I'm quite happy that my daughter wants to be a beautician and a nail technician. I'm going to say three things, Jay, and then we can jump into these three topics. The first thing is traditional software development is dead. The second one, SaaS is dead. And the third one, I was going to say time and material contracts are dead, but that would be like we're having a big fat funeral. But time and material contracts are certainly becoming obsolete, and businesses are certainly going to have to look at the way they contract with enterprises. Let's hit the first topic. Traditional software development is dead. Jay, give me your first impression. If somebody had said that to you a few years ago, what would you have said, and how do you feel about it now?
Maybe what I should do is just give a few seconds of the background, from where I come from in the context of software engineering rather than computer science. Let's just think about science versus engineering first before I talk about that. So science normally is when you run an approach where you have got an hypothesis and you're experimenting and you don't necessarily know what the answer is and you are exploring various options. Engineering is when you have a very well-defined body of knowledge and a very well-structured discipline with all of the eventualities mostly worked out so that you can get to a point of producing something highly repeatable and that that you can get to a point where you are highly capable. Or if you look at software engineering practices like maturity models versus capability models, two different approaches, but the point is that your end game is, can I do something highly reliably over and over again so that I can plan for it? And I think that initial thinking is where most of us who came out of that kind of early engineering world kind of saw it. What changed it was that if I think of my biggest software company had probably 450 developers in it, give or take, scattered around the world, South Africa, Europe, UK, and then in the US, 3 different locations. And if I had to think about, in the days when we worked with it, like, let's look at the early days of APIs or the early days of something like UIML, the user interface markup language that eventually became the drive behind React and Angular and Vue and all of the frameworks that dealt with, in-browser updates and so on. Everybody was trying to find that answer. Remember, we used to run Adobe plugins and you had 20 developers working very long hours, extensive amounts of time. We were documenting what we needed to do at an enormous amount of detail. We had to architect and design it. We had to think about it incredibly carefully, because by the time you kick off this machine, to code it, you can't turn it around because the cost of redoing things and a rework is just too high. So you sit with this technology debt and you just keep on adding and you're extending and you build a platform that you hopefully can reuse in other places. So I got into product line practice. That is the concept around how do you separate commonality from variability. And that meant that the reliability of the architecture is entirely kind of hinged on an individual that is a domain specialist. Your ability to think about what a user might ask 1 year or 5 years from now, because that's how long your product's going to be in production for. So Taniki and Eisenecker, who basically was the two architects behind what's called generative programming, try to create this way in which software engineers need to think about reusability, because reusability is incredibly tough. So if you over-design things to be reusable, you've got this incredibly complex, almost impossible to change mass of software that if you touch one thing, 10 things are going to fall apart. And on the other end, if it's only built for use, you need an army of people to build it, because if you're going to replicate the code, it's easy to get it done. You might get 5 products out the door quickly, but then you sit with 5 lines of maintenance downstream. So those challenges for the people who have been in the software world, I mean, we are acutely aware of that. So now when we build the same thing, I mean, I was just listening to some friends that run a podcast in San Francisco again this morning. Yesterday, they had a podcast last night. The whole concept is to say, well, maybe the future is, and let's just take like an extreme future, where if you're not happy with what is going on right now in your enterprise, you should be able to generate the system overnight if you have a reliable approach. And tomorrow morning, you should just carry on. And, you know, Matt, that's really been our ecosystem code story, is that, you know, I should go from an idea to a spec in an hour, and from there to a system in another hour. And I should be able to replace, you know, things that used to take armies of people to document, to spec, to design, to architect, to implement. That entire cycle should get to a point where it is in hours, so that the pressure goes elsewhere. So I think that there is definitely a radical rethink going on while companies are grappling with this deep challenge of conservatism. Because they think that they've read in the public, vibe coding is breaking systems or it's not working. And as you know, that's not true at all, because the AI tools that you use were entirely built using AI. So that means that the documents that you read were mostly written using a human oversight. So where does it draw the line maybe from the past going forward? So I think that your question is probably, you know, far bigger, you know, a situation to answer than just looking at it as a kind of single case.
Yeah, 100%. So I was invited by one of our banking clients to come and chat to 30 IT executives. I said, listen, I'm going to have to bring one of my guys. I'm not a techie. He says, I don't want a techie. I want an entrepreneur that started an AI business that understands what's going on in the world to scare the shit out of them, excuse my French, so that they can stop being complacent and stop hiring tons of devs and working in the same traditional way, because we're not going to be in business if we carry on working like this. So, I mean, that was quite fun, trying to scare a bunch of IT execs. I even went to the extent of showing them that Mr. Beast, who's the YouTuber, has just bought a bank. That's their future competitor, because he can build all the systems that they've got using AI. And I think the nice thing is this specific bank is actually really grappling with, how do we change? Now, we do have a big development shop. How do we change? And I spoke to one of the guys that have set up the AI infrastructure, and he said, you know, he's had his guys, he's pushed Kiro and pushed a whole bunch of AI tooling to them, and they'll work a little bit with it, and then they'll go, oh, no, but it didn't do this really nicely. And he said, no, bullshit, do it again. And then they come back, it worked really, really well. But do you think there's going to be enough work for that and me to be here? So that was the real challenge. Yeah. Of course, he said, think about how many projects we didn't do last year because we didn't have enough of you. Now we can.
Yes.
So it's more like a reorganization, but that's also a worry, because a part of my conversation with this crowd was, what are we going to do with our junior and intermediate developers? Because the tooling will make them obsolete. So how do we grow an engineer from a grad to a senior, which we need, if we don't need juniors and intermediates?
So maybe 2 things there. Can I just maybe give you a quick comment on this issue with the junior versus senior and the role that any computer-related education is going to play in the future? So I had this conversation with one of my daughters at length, and she did very well at school, math major, science, all that sort of stuff, bunch of distinctions, got into university, and she wanted to do math from young. And actually, when she was very young, she wanted to be an astronaut. So we used to go visit NASA in Palo Alto all the time and that sort of thing. And we had a long conversation about the concept of logic and then the concept of thinking. I had this conversation with my kids from very young. Is that the purpose of math is not to memorize an axiom or a quadratic equation or some algebraic formula that you have to reproduce because the teacher said so. What you learn is the ability to get your brain to function in a way that amplifies your capability as a human. What programming did for me when I was younger was not necessarily the code that I produced. It was the ability for me to stand back from a situation and being able to reason through it in a way that I know that there are boundaries within which you can and cannot do it. And there are certain rules that apply that I have to use in the context of what I'm doing. She's busy doing applied math and computer science and AI and genetics in the process. So that means that that kind of thinking, I think that kind of kid that's going to enter the workplace is not going to, they're going to come with an uncontaminated mind. And the uncontaminated mind, I think, and especially in the stage where I'm in my career now, is radically undervalued. And let me tell you what it means. If I look at I see Graham's getting, him and I chat often about this sort of stuff about how, some people, maybe like our personalities, are naturally interested in change. And actually, if it's not there, I create it so that I can thrive in it. You know what I mean, Matt? And that is for a handful of people who naturally do that. But people like us cannot function if I don't have somebody around me who can execute on the new idea, because otherwise you have nothing. You only ever have new things that never can be sold and never can be commercialized. So you need this balance of the two. So I think that this new kid is going to come through. Zoe in high school built an interpolation model, worked out how to do Python, spun up a cluster in Palo Alto, and kind of just did it because she had already the ability to reason through the details. The full stack people that I've been engaged with, the banks like you talking about that I've been talking to too.
Yeah.
I'm not sure if it's the same banks, but we've talked to a bunch of them.
Yeah.
They all sit with this challenge in that the person who got to a certain position got there because they were incredibly good at doing what they used to do. And the problem is they're not going to get there by doing what they used to do. And that there, they have no concept of what there is. So the new generation that's coming through the ranks only understands the there. They don't think that coding means sitting down and punching out a program. They're not educated that is what you should be doing. For them, it's a bit like if you were born in an age, when you only knew CDs or vinyls, you believed that music was only delivered through product. If you are born now, my kids have got 1 or 2 CDs on their shelf, and they've got some of them plastered on the wall as reminders of what the world used to look like. They've never played them. I think they might have played them at some point in their history, and it was novel for about 10 seconds, and then go back to their Spotify that they stream 24/7. They have no concept, and that means that the person who still got the collection wants to play it because I've invested in it.
Yeah.
And I think that challenge with programmers that get then emotionally connected to their tech, for me, is probably one of the biggest crises in enterprise that is going to create probably one of the biggest upsets in the software engineering world. And that means that I meet people in places like South Africa who is obsessed with Microsoft stacks.
Yeah.
It makes no sense because Microsoft themselves behind the scenes only run Ubuntu. It's bolted on a Linux stack. Satya Nadella is retooling the entire organization, and he has to keep this old thing going because a bunch of people around the world in places like in the southern tip of Africa are only interested in doing that because they only have that understanding. They have not been able to stand back and go, there is something entirely new out there.
Yeah.
There's an entirely new way of producing the same outcome. So if I look at the way that we're producing, even in our own business, I think that the ratio of the work and the products that we've released in the last year, let's just take the last year for now, not even the last, let's say 2 years.
Yeah.
We've almost entirely reconfigured our dev teams, and the people who are in the core are the people who can think. And that means that there was a time when mechanical and industrialized software coding could be a business. The industrial coder who said, I understand nothing about what you want, Tell me what I need to do and I'll do it for you and I'll give it back to you. And with that came all of the practices like Agile and the waterfall methods and all of the things that came from the early days were all shaped around this problem of the person doing the work not knowing what they need to do.
Yeah.
I think that entire concept is going to be disrupted almost entirely.
Yeah.
Because now that idea to delivery is getting to a point where it's almost zero.
Yeah.
In relation to, because our vision, and even in ecosystem code, our vision is, can I sit in a meeting with a user, punch out a story, or let them punch out a story, and generate their entire system for demonstration to see if they're going to like it or not in that session? So can I spend an hour reproducing that to build a POC, to go create, remember the concept of, there was once a time when people used to care about MVP. Remember that? I think that is being turned upside down. You don't do MVPs. MVP is what you do in the first 10 minutes. You generate it out and you say, yes, I've got a minimum viable product that I can market. Okay, now let me create a minimum marketable product an hour later. Let me create a minimum viable productionizable product 2 hours later, and then test how the market adopts it. So now you're going to have to come up with a new acronym for this, because now it's about minimum viable usefulness, because you can make it so quickly. So it's not about the act of production. It's about the act of thinking and the act of usefulness. So I think that pressure that used to be concentrated in the software engineering process is now being pushed to the people that think what needs to be done and knowing exactly what needs to be done to become successful. And on the other end, the people who are going to use them is your ultimate test, because if they don't use it, you have nothing.
Yeah.
You have to restart, but you can restart a lot quicker than you could because you don't have this massive engineering dependency.
Yeah.
Anyway, so that's just a bit of a.
No, it's just,
I think Graham's got his hand up.
Just a couple of comments. I think you're absolutely right. I saw a very interesting video recently, which was talking about the need that we still have a need for senior engineers, because they understand all the sort of subtle bits about putting stuff into production and things like authentication and reliability and verification, usability, and so forth. And that's absolutely right. And the problem was now, as you were saying, Matthew, how do you bring people into the industry and have them get to the senior engineer level with those skills and that knowledge without going through the trenches for 10 or 15 years doing the development and bumping their toes and learning by osmosis. And the conclusion was that the core skills are actually systems thinking, in terms of understanding context, understanding users, understanding machine-person interaction, understanding the core of the domain data, understanding where data is going to live, where responsibilities are going to live, all of the issues that are systems kind of problems, system thinking problems. And I think that's actually a very interesting perspective, that those are the core skills we actually need to be teaching juniors now.
And is that like with architecture? I mean, like your game, is that because an architect's core skill, I believe, of the really good architects that I've seen through my life, are the ones who have been able to stand back and observe the understanding of a system and then have the ability to describe it. And that's why I think that if you think what happened in the AI world, that's why there's a thing called spec-driven development in the AI world. Spec-driven AI development is a core part of what we do in the ecosystem code environment as well, is that I still need to have a reliable definition or description of the world that I'm observing. Because if I produce an outcome that is entirely free to produce what it can produce, I get what's called the agents of chaos. What I maybe can do, I don't know, Matt, if this is maybe a good time, I've got a few academic papers. It's like my top reads for the week. Now, I only read at least one paper a week, one a day at least, and then I summarize a couple of them a week for myself so that I can just keep up with this, the academic world here. So maybe I can share a few of those. Should I do that? Just to
absolutely. I think it'd be good. I think the audience, I certainly would like to. What's also quite interesting, just from what you're saying, Graham, Jay, is that these younger people that come through, you're not put into a corner and given a bunch of tasks. And yes, you might have an idea of what the system's going to do, but you don't really have the ownership. You have to do the mundane little tasks that the seniors aren't going to do. Now, when you talk about spec-driven development, you need to understand how the system works and how the system's going to be consumed and what it's going to do, because the coding part's going to be pretty quick. It's just you've got to make sure that it does it right and it can be tested and stand up in an enterprise space even if you're a junior.
So that's what I'm thinking, and why, like, let's take my daughter again as an example, as a bit of a risk that I took in giving her this advice. And for now, she's taken it. So let's hope that I'm going to be okay about that definition in a couple of years from now. I said to her that if you had to think of in the age of the steam train, the era lasted for 200 years or 100 and plus years. And the person that shoved the coal could only shove the coal because that was the labor of shoving the coal. The person that built the railway line knew how to lay the tracks. So they were the people that's like the programmer. But the person that designed the railway and the person that decided that maybe I need to replace the steam with electrical or with diesel or with some other mechanism to get across the railway line that's already been laid on top of the existing platform, I've got endless opportunities to rethink how the world works for a period of time. And that means that we maybe come out of an era with this hyper specialization in a singular coding technology, singular environment. I think that is going through a massive rethink too.
Yeah.
And so if you look at these handful of papers, I've got 4 here and another 4 in this section. Let me just talk through them quickly, and I'll give you a broad spectrum view just in a couple of minutes so we can maybe come back to these. The first one is diving into Claude Code, the design space of today and future AI agent systems. So everybody at the moment is thinking that the agent is going to solve all of these problems. The next thing is the spec-driven development from code to contract in the age of AI coding assistance. So that means that how do I get these agents that I want to use to perform in any way? Because I need to tell it that there's a certain standard, there's a certain naming convention, there's a way that I want to store my data, there's a way I want to connect my security, there's a way I want to do messaging, there's a way I want my user interface to look, there's a way that I want these things to be done reliably, and I want to be able to design it for the domain that I'm in, the industry that I'm in and everything. So that means that if you're just going to jump onto some vibe coding environment, you start from nothing. You don't even have a railway line. And you want to build a new way to ride on a platform that's been created by somebody else. You think, no, I'm going to build a railway line next to the one that's there, and it's going to go all wonky, and you've got no idea why it does it because you never thought through why it's there. And that's what spec-driven development is trying to give you. But then AI first software development lifecycle says, well, if I do decide to do this, how much of this can I then do autonomously? Because I can spend an enormous amount of money in agents to figure out that my tracks are not in line. And every time it lays it wrong for periods of time, go fix it. You need a deterministic reasoning framework. You need a way to think about the world differently. You cannot think that a generative tool is going to keep on generating the wrong thing and your job is to fix it. It's not good enough. And that's the one thing that you learn as an early developer. The first thing that you learn is doing it right the first time. Educate yourself. Make a mistake, delete it. The next time you do it perfect. So why do we still accept that paradigm in vibe coding environments? And then that last paper, that's for me one of the most fascinating ones. It was published first in 2014. I saw it was repurposed 2 days ago. It's called the Platonic Representation Hypothesis. The basic concept goes like this. All models that use neural nets, that at the moment, is basically 100% of all models. There's no difference between Anthropic and OpenAI or X or any of the big models. If they all train from the same data, they will all converge to the same answer. The only thing that differentiates them is somebody that has made maybe some table change, some change. And that's why if we look at the coding comparison of models that we use, like Quen or deep learning or something we get from Asia, outperforms Opus 4.7 because they sit with an enormous problem around token price. I don't know if you followed what happened in the last couple of weeks with Anthropic. Because they ran out of compute space and cost, what did they do? They throttled the models. And the world is freaking out because none of the stuff that it used to do well a couple of weeks ago, it does well now. So you use the most expensive model. You pay $1 to $5 to $10 per million tokens. You burn millions of those per day. There are people that I know that spend $10,000 a day burning these things to work. And the thing is performing far worse than an open source model you could have hosted on your own infrastructure. So that means that I'm deeply interested in this topic because if you follow the same concept of a programming language and you know that it's got a very specific set of rules, you need to think about the world in that particular way. If you take, like in this case, images and text as X, Y is the projections onto a common underlying reality, and that reality is what's called the latent space. And you keep on providing it with the same, you see that the conjecture that representation learning algorithms will converge on a shared representation of Z. So you can take the same model, produce the same kind of output. And that's why you'll see that models that were trained on history, on language, on content, are not so good at programming. You don't want a model that contains the US library and Wikipedia generic definitions in its core. That's why Codex exists. Models with Opus have got a special flag that they set for coding only, or why QuenCode or DeepSeek Coder or all of those exist, is because the moment you throw in English language into coding, it doesn't know by the time the model converges that the definition of somebody who's written a story with Stephen King telling you how the world's going to change, if that was maybe a description of what used to sit inside a program. Because remember that once the model is trained, it doesn't know where those fit. Anyway, so that just means this is a great paper to work through for all technical people to understand by the time they select a model. And then if you want to go AI first software development life cycles, you need an entirely new way to think about your layering. You need to think about the way that your product and your design layer is now basically amplified in importance, all the way through to the fact that if you're going to have a swarm of agents doing work for you, that's like having, and the way that we explain it is you have a 10-year-old and a PhD in a room with you. Those are your two employees. The PhD knows everything but can't do anything. And the 10-year-old can code like a junior can at a pace that is unbelievable because they're energetic, but they got zero of the knowledge a PhD has. So when you communicate with your tool, you have to tell it, the PhD, to go fetch the knowledge and tell the 10-year-old what to do with it. And that means that that kind of construct is what engineers were never trained on. Engineers were trained on. If you are a qualified software engineering person and you've gone through the software engineering body of knowledge, you know it all. You've been certified that you know it. But now you sit with a company because of this problem that we are still converging. Remember, the conjecture is saying that it will one day converge. We are still on that journey. It's not there yet. The models give you different outputs. And that means that your layered architecture using the 5 subsystems, this is Claude Code's core architecture, by the way.
Yeah.
So if you had to take this entire architecture, why does it need 99% of this? Is to solve one simple problem in the fact that the person is going to want to do the same thing over and over again reliably. And there is no simple architecture in practice today that can solve that for you unless you go deterministic. But the moment you go deterministic, you are not narrow anymore. You now go up the stack.
Yeah.
So that means if you want to build a narrow generic for use, you have to have all of these components in place. But if you build a deterministic system, the layers look nothing like this. Because now, nowhere in here does it explain to you that a company or a corporate or any corporation wants to have naming standards so that it looks the same and it's maintainable over time. Nowhere in here does it tell you that there's a thing called data referential integrity, primary keys, and the way that you want to store numbers and the like. Nowhere in here does it tell you what the concept of a workflow is in the context of a business application. Nowhere does it tell you what the concept of a specific security framework is or anything of the sort, and so on and so on. So that means that nowhere in the generic coding, vibe coding platforms, is there any assistance to help the business person build an enterprise stack. Those are missing, all right? And that is what we've been trying to work on, is to say, well, if I'm going to do that, and I want to use, and this, by the way, is also, I think, an amazing paper. Everybody, I think, should read this, business and tech people. Because the concept is, all models will break your code. Why? Because they're generative. What does it mean? That means that it's probabilistic. It means that there is no way you can control it. It is not a deterministic outcome. So that means that you need to have a framework, an entirely new way of thinking about software engineering that you did before, to really allow changes where you know that it's isolated. There's a new way of thinking because you have this concept of agents doing things that they're not supposed to, and they keep on breaking things. They might delete a security file. They might change a tiny naming of it. They might change a parameter. It doesn't tell you that it's done. You can have in Cursor hundreds of pages of rules.
Yeah.
And you say to it, why did you break the rule? It says, I'm sorry. Or you go to, Claude Code, Claude.md. You can fill it with as much as you like. You can create even skills tasks, and it comes back and it's stored, and you go, why did you do it? And it comes back, I'm sorry.
But that's like a junior dev dropping a database in production.
Exactly. That's a 10-year-old that's just doing things. They got no idea why they're doing it. And the parent said, why did you do it? He said, well, I don't know. It's in my nature. You don't know yet. You have no discipline.
Yeah.
And that's partly the challenge. The other thing is that the agents of chaos, I just thought I'll show this. We can share this afterwards. But this is kind of just what the paper is about. Critical failure modes, like unidentified spoofing, and the whole thing around hard adds hidden code, because the code that it might have been trained on is about, back channeling. the way that it uses resources is just, its job is to do that because that's how the company that you buy it from is making its money. It's disproportionate nuclear response. That means that it keeps on taking non-owner secrets and variables, and it changes the names and it adds security things all over. You get the picture. It's got all kinds of challenges. The other thing is that context construction and memory hierarchy, I think, is going to be an enormously important thing for people to understand going forward. And that means the concept of a context window and what gets placed in there. And when you set a rule in your AI tools, all that it does is that it goes and fetches a systems prompt. And that systems layer, what's called the startup, the systems prompt with the environmental info and the names, still means you just burn 10 times more tokens. It's good for business. And the problem is the developer thinks, oh, check, my code is being done. But you don't know that all that it does, when you run RAG, what does RAG actually mean? Retrieval augmented generation. All that it does is fetches content and adds it to the system prompt. Its job is not to make it clever or anything of the sort, actually. It is just adding it. So the context window is sitting with 1 million tokens, like you find in DeepSeek. I don't know if you saw DeepSeek version 4 just dropped like 2 weeks ago or a week ago and a bit. I mean, it's fascinating. It's got a enormously big context window that you can drop an entire set of programs and everything into to do work for you. But what does it cost you? And then as you work through like the project configuration, the memory, the conversational parts that you carry in the context of how you would want to build your code, all the way through to the on-demand, what's called the lazy, deferred tool definitions, and the like to go fetch and do work for you. All of this forms part of your context construction to get the job done. And then this paper called The Future of AI-Driven Software Engineering basically is probably one of the few that I've seen that have taken a fairly realistic view on how I think it might end up. And this is maybe just a quick glimpse of on your first point and maybe tying into one of your other points, is that requirements engineering is not going to go away, but it's going to get compacted. Why? Because you still need to have an interpretation of a human intent into describing it in a way that is reliably defined so that you can produce it. And that is what that phase does. Right. Software design then is you still need to decide your target technology. You are still talking to a machine. So that means that if you want to target a SQL database, NoSQL database, C# or Java or Rust or Node, or if you want to target a user interface that is maybe a dedicated web app or a browser app, whatever it is, you still need to know that architecture. You still need to know that design. You still need to pick the design that is appropriate for your implementation. And maybe you want just to use the default, but who decides the default? We decide the default for you. You know that. If you say default, we pick React front end, Node middle tier, Mongo backend. Why? Because we think React is probably one of the easiest front-end tools to maintain over time. It's maintained by Meta and a few companies, and it's open source. Why do we support Node? Node is the fastest back-end tool that you can run. It scales, it's secure, it's incredibly lightweight, it doesn't take a lot of compute. And you don't want to sit with a SQL hell. So you want to run a NoSQL database, Mongo or otherwise. But the point is that if you don't pick anything, we just generate out for that environment and it runs out of the box. But you can then go decide what you want the target to be. But you first need to know what your requirement is. And then your development and testing should be deterministic. Click a button and it produces an output. Why? Because you already have your thinking done. Your spec is done. And then the challenge starts with the maintenance. The question is, there's a thing there called bug reports. If you have a deterministically generated system, can you generate 100% test coverage in the process? That was never possible with a human. Because if a human has to manually go and create logic charts and work out what testing they're going to be doing, it's almost impossible to find all bugs. The bug is to find something that a user didn't expect. How will it know what a bug is unless you have a requirement? And the requirement must be designed. So we use UML for the front end. This is just showing you that agentic coding versus vibe coding are two entirely different sets of practices. And that means the one using a lot of deep agents and like MCPs that are bolted into your tooling, and vibe coding, the fact that you just start punching out, ask for questions. And the paper is coding with AI. It's a great paper. This is a good paper on spec-driven development. They're saying that the human review is still human in the loop for every stage. And that's why you see that on even ecosystem code. If you specify your system description and you click analyze on our tool, it analyzes that description that you gave us, including you might be able to upload an ontology. And it will then go and give you a definition of what it is. Then what you want to do is you then want to plan to say, how am I going to build this thing? And you can then decide that once the models are generated, how you're going to build it. You can pick the target architecture. The implementation, you can then decide how you deploy it And eventually, by the time you validate it, you can then see that, yes, it's doing what it's supposed to do, including synthetic data and the like. But I think that the human in the loop, that's why I quite like the way this paper is structured, because Deepak, the guy who wrote this, you could see that he was a very deep practitioner in the fact that he's been building utilities to do this. So we quite like this approach. And then one last thing is that while your tooling is running, you want to use tools like these. This is a live simulation of code being generated by an AI tool, and you checking that it's actually complying with your reusability and your naming conventions and your standards. So that means this kind of tooling will emerge over time, where it keeps on tracking what you're doing, if it's going to do it dynamically. So what we do is we do a deterministic environment. You run this kind of tooling on top of it, you extend it, and it'll then show you if you're breaking the build. That's why I like the way you picked this topic for today. Because whoever breaks the build gets the lash. They are in trouble. Anyway, yeah.
And this is all on the ecosystem code site, right? We can all go on there. And
some of these papers are not there. If people want it, they can just go to Discord. Go to our website, go to Discord, and we'll post them. I'll make sure that I see Christina's online, but we'll post them on there so that people can go read them. But there is a concept, and maybe just, Matt, I know that I'm taking way too much time with this thing now, but if I just show you this quickly. Autonomous software engineering, this is one of our other papers, just to explain, how you build reliable systems. Words, UML for your spec and in your running code. How do you take your tool use all the way through with your evaluation so that you can have automatic fixing? How do you deal with what's called the 7 rules or the 7 layers? So you got your project description, UML, source, domain, enterprise cloud references, especially if you're going to go to a certain cloud provider, you definitely want it to be deterministic. Because that version of cloud at that moment with that database, with that design, and that version supports that feature, you don't want the tool to make mistakes the whole time and you're burning cloud cost and token cost. You want a deterministic target. So we've been spending a lot of time on making cloud targeting highly reliable. So that means that reliable enterprise code does not need vibe coding. It needs system engineering that is AI enabled to get to reliable outcomes. So there's a new way of thinking about this. You need a new way of designing what you're designing. So that means your pre-generation validation, your deterministic post-processing, your validate-only mode, your whole auto loop finally check, your fallbacks, if you have fallback systems that is going to analyze it, your pipelines for diagnostics, and then your human escalation, if something goes wrong, that you can still have that senior person or a junior person if they specialized.
Yeah.
And look at whatever needs to be fixed. And that just means that your new practices are evolving in an entirely different space. Anyway, the idea was not to go through this deck, but we've got a complete story as to what those core elements are that would normally be needed for this kind of thing.
100%. But so then let's lean into that a little bit. I know we've only got 10 minutes left. The next sort of area we spoke about was SaaS is dead, and you've kind of leaned into it a little bit around systems that are deterministic in their approach. When we were at the dinner the other night, I was sitting with one of our clients from one of the large telcos, and just after your talk, and he overheard you saying, your challenge is to take a large CRM, I'm not going to say which one, and be able to rebuild it. You've changed you're like one of those fishermen that the fish keeps growing every time you tell the story. You wanted to rebuild it in a month, then it became a week, then it became a day, and then it became an hour.
Remember the tech's evolving.
Yeah.
When you heard it the first time from me in November last year, I initially thought it was going to take that long.
Yeah.
When we eventually finished that cycle of R&D after months of work, it turned into a week, and then it turned into a day. Right now, you can regenerate an enterprise banking or telco CRM, customer lifecycle management, CVM system in less than an hour.
Amazing.
So that is our parallel architecture that is implemented now with the deterministic environment. In this time frame, we could compact it.
Yeah.
So it's still valid.
So he heard you say that, and he looked at me, he said, do you know our business just announced that we are implementing a new CRM system, and in 3 years it will be fully implemented? And he said to me, I'm writing a letter to our CEO after I heard Jay talk, because this is crazy that we're going to spend 3 years of how many developer hours buying a platform it's a SaaS platform that's already been developed, and it's going to take 3 years. And probably, if we know how these large platforms go, close to the billions once it's implemented.
Yeah. I think that, and that's what I said at the dinner as well, and what we see as one of our primary purposes in life.
Yeah.
Is to upend that entire industry. And we are one of if I look at Crunchbase or AngelList, and just in a startup world, there must be at least 2,000 of us around the world right now. So we're by no means unique in our vision, but I think that it's the execution that hopefully will separate us from the rest.
Yeah.
That means that, in quotes, there's a saying by one of the VCs in San Francisco that said that it's a Frankenstein enterprise systems that are the next fair game for all of startups in the world. And that means that enterprises are moving away from spending hundreds of millions on product implementation, on bloated systems that were acquired over time that you're going to use 1% of its functionality and then spend years customizing it to attempt to make it work for your business and think that the outcome is going to be positive.
Yeah.
That means that OpenAI Enterprise Division and Anthropic Enterprise and even Grok, and that the OpenAI case is going on right now with Elon Musk. It was heard yesterday and it's going to be heard again today. That this week we're going to hear the outcome of that case. I'm keeping a close eye on it's in California at the moment. So that means that the point of all of these companies fighting for where they're going is to take over the enterprise stack. And the enterprise stack is that stack that used to be there. And that's why you see Satya Nadella, the only CEO who stuck his neck out at Microsoft, because he knows Microsoft Dynamics is one of that. We regenerate Microsoft Dynamics. I can give you all the functionality plus your industry specialization in an hour. You don't need to go spend millions. And he knows that.
Yeah.
That's why they're retooling the entire organization to be able to fix that kind of problem. So I think that's why the share price drops that we've seen in all these companies, that's why it's called SaaSpocalypse.
Yeah.
The SaaSpocalypse is essentially the death of, I'm going to buy some functionality from you that was some workflow assistance, whatever it is, because I'm going to generate it myself.
Yeah.
But
when it stops working and doing what you needed to do, you just build it again.
And that's kind of, so our go-to thing. So what I do on my phone is I've got an agent connected to ecosystem code backend because it's got an MCP. And I just explain to it what I want to build while I'm driving on my way everywhere. I build models all the time. I build new applications 24/7. Why? Because we don't use OpenAI or Anthropic. So I don't burn the tokens the way that they are expecting you to burn. I use models that are more reliable for enterprise implementation. And that means that you don't sit with that enormous bill that you normally would have to pay, because you are accessing a model that is incredibly large, where 99% of what's inside that model is about law and about medical and about travel and about all kinds of things got nothing to do with coding. So you need that rethink as well, is what people have not got their minds around. Because, there was this most amazing marketing hack by Anthropic recently saying that our models are too dangerous, so we're not going to launch it. I don't know if you heard that in the market.
I did hear, yeah.
You know whose playbook that is? If you go to any hacking marketing workshop in San Francisco, they tell you that you have to do that at least once in your life cycle. And you know who did it first? OpenAI did it with GPT-3 in 2018, said exactly that. They launched it, headline. I was actually in San Francisco. I was in Mountain View at the time. I was busy with some Y Combinator people because we were at the time thinking maybe doing something there with our business. And I can tell you now that is exactly, they had it once. OpenAI, their version, Anthropic at their version. Elon Musk, now that he's bought Cursor for $60 billion, is going to do the same in another month or so. You have to do it at least once in your life. So maybe we'll try that too with ecosystem code. It's too dangerous because you're replacing your enterprise system too quickly. How many people are going to lose their jobs or going to manage this thing? That's what everybody's worried about.
Yeah.
And maybe this, Matt, the last thing that I maybe just want to say about that, what I found that was my probably the most interesting thing for me was the definition of change management as per San Francisco. It goes like this. You make sure that you check your entire organization, their use of their prompts and of their AI tooling across the spectrum. And the people that have used no AI, make sure that your OpenClaw, your Clawbot, automatically sends them a note to say, go home. So that was the best definition of change management that I've heard in recent times.
No, I like that.
So what's going to happen, though, is that what does it mean for companies who are not on that?
100%. And we didn't even really get into the meat of things because we've upset a lot of people and told them that things are really broken and they're heading down the waterfall and there's no stopping them. I think we probably do another session in my next partner session to pick up the time and materials.
That's a good discussion.
I mean, if you think about some of the large, I work for an organization, ThoughtWorks, they were phenomenal. They contributed hugely to the Agile movement. They probably 10,000 plus developers now. If you go onto their site now, they don't look like a business that makes money out of dev hours. They've had to come across, and I don't know if it's really good window dressing or it's a really powerful proposition, but they've got a platform. You buy into the platform, and it's an AI platform that has got guardrails, and then they develop through that platform the outcomes that you want. So I think we should jump onto that subject next.
Matt, I think what you guys should chat about as well is the way in which Agile, in a business like ours, we don't use it at all because it's too slow. So that means that if your sprint time now is 2 hours, and we do 5, 7, like last week was incredibly productive. We did on average 5 releases per day per product that were under review over 2 or 3 product lines at about 20 or so. And that meant that you could get things out. Historically, it was about creating the PR and getting the test done and whatever it is. Now, the test coverage is done by the time you're done.
Yeah.
So that means that you build and you test, you check this backward compatibility, and you deploy. The moment you deploy, it's in production. So we're not quite where Google or those companies are. We do over 1,000 releases per day, but for our size business, I think we're comfortable with between 1 and 10 a day is a good cycle to kind of cover. But anyway, that'll be a good topic to discuss.
Definitely. We haven't even had time to get any audience.
We've got a camera on. Maybe there is a question we need to answer.
My question is, are there any questions?
Yeah, guys, thanks again. Very interesting talk. We actually had a follow-up discussion with one of our clients for whom we also gave a proposal on human-led AI-enabled development project. And yeah, they were very forthcoming in the discussion, making it clear that even within their grouping, there are 2 sides to the whole AI adoption process. Some are anti and some are pro-AI. And ultimately, you'll have to buy over the skeptics by proving to them how it works. Interesting to see sort of universal, like everybody has it. That both those who fear AI and I guess those who don't really understand it. But yeah, I guess we'll have to teach them. But thanks.
Thanks, man. Maybe just a quick story. So in my very first job, I used to do embedded systems coding. So to change a report in 99,000 Texas Instrument assembly, you had to basically change it in assembly. There was thousands of lines of code changes that might have taken to change the report columns around. Would have taken maybe 2 weeks minimum of base work plus another couple of weeks of testing before it can be deployed. So when Aztec C came along in our dev teams, I was a young guy, so it was kind of easy for me to say, well, of course, Aztec Grommable C, I'm going to go that route. I could change the report in 1 day. It was a miracle that I could swap the columns around in 1 day. And I said, there's no way this is going to work. Anyway, so every generation, is the point of my story, I felt in my career, there was always this part of the people who said, this is not going to happen. And when you have an inkling and you look at the outputs and you see how much more productive you can be, then the results, like you say, speak for themselves.
Yeah, like you said, the vinyl guys will always say that scratchy music is the best, you know.
Maybe sometimes it is needed, you know, for some nostalgia, but the kids don't understand it.
Nostalgia, indeed.
Yeah.
Anyways, thank you so much.